Hello and welcome. In this video, we're going to continue looking at systems in 3 variables, linear systems in 3 variables, and we're going to take it a step further and actually apply it to word problems. So we're going to look at real life problems. We're going to focus on defining our variables, translating the English sentences into math sentences, setting up our system, and solving. So let's go ahead and jump right in. So here we go. Anytime we are working with word problems, I think one of the hardest things is really to take the words that are there and translate it into the math that we are being asked for. So we're going to focus more heavily on that part today and not as heavily on the working through the system, even though we are going to do that. If you're struggling with, towards the end of this lesson, if you realize you're struggling with the solving and not the setup, then you can go back and watch the video before this. But if you're struggling with the setup, which is the real focus of this video, then I want to make sure you're getting that support. So anytime we're doing a word problem, we don't have an X or a Y necessarily that's being defined. So we want to start by defining our variables. Pick letters that make sense within the context of the problem. If you're talking about dogs and cats, use D and C. But use something that's going to help you understand and be able to relate your answer back to what the original problem is. But specifically start by saying let X equal or let D equal the number of dogs. Something along those lines when you're setting up. That's what I mean by define your variables. Then you're going to read each sentence and translate those sentences into math. That's the part I really want to focus on. And then you're going to solve the system that you have using the same strategies that we used last class. And then you're going to check that your final answer makes sense. Do you have a negative number? Can that work in a problem like this? Do you have a fraction? Does that make sense to have a fraction of a seat or something along those lines? So really make sure that your final answer does in fact make sense. All right, example 1. An amphitheater charges $75 for each seat in section A, $55 for each seat in section B, and $30 for each lawn seats. There are 3 times as many seats in section B as section A. The revenue from selling all 23,000 seats is $870,000. How many seats are there in each section of the amphitheater? So I really like to read through these problems twice. Once to get an idea of what in the world this problem is talking about and what it's asking for. This problem is talking about different types of seats in an amphitheater, and it's asking me for how many of each type. When I go through the second time and read, that's where I'm really going to be writing my equations. So looking back, it talked about 3 types of seats. Seats in section A, seats in section B, and lawn seats. So I'm going to go ahead and define my variables. I'm going to let A be equal to section A tickets. I'm going to let B be equal to section B tickets. I'm going to let L be equal to lawn section tickets because those variables make sense to me within the context of this problem. So here I've defined those 3 variables, A and B and L. So when I write equations, I'm going to have equations in terms of A and B and L. Now I'm going to go through those sentences again and come up with 3 equations. Since I have 3 variables, I'm assuming I'm going to have 3 equations that I'm going to use. The first thing I notice is that I see some dollar signs there. So I'm going to look for an equation that involves all the things about money. And I'm actually going to call that my money equation. You don't have to label it like this, but it helps me see what I'm doing. I'm going to use green for money because that makes sense to me. An amphitheater charges $75 for tickets in section A. So mathematically that means 75A. It charges $55 for section B tickets and $30 for lawn tickets. So plus 55B plus 30L. And then I want to know, this has to be equal to something. How much total money are we talking about in this problem? It doesn't say it in this sentence, but if I keep reading down below, there's another dollar sign, and I see it here. The total revenue was $870,000. So everything in this equation deals with money, my money equation. The next thing that I'm going to do is just continue reading in the next sentence. The next sentence says there are 3 times as many seats in section B as there are in section A. So I'm asking myself, this one really sometimes I have to think really hard, is this saying that 3 times B equals A or 3 times A equals B? So what I need to ask myself is, which number or which section has more? There are 3 times as many seats in section B as section A. So which one has more? Section B has more. That means that B is equal to 3 times A. B has more seats than A, so B is equal to the number in A times 3. So I have my first equation, I have my second equation, I need one more. So the only number that I notice right away that I haven't used is this 23,000. And what is 23,000 talking about? It's talking about the total number of seats. So the other equation that I need is my totals equation. So the number of seats in A plus the number of seats in B plus the number of lawn seats adds up to be 23,000 total seats. So now I have my system, and now we can work through the steps that we did yesterday. But I really want to recap that process because that's what today's focus is. Start by defining your variables, then go through and underline and highlight and circle and read each of those sentences and translate those sentences into math. Now we're going to move on to the second 2 steps. We're going to solve the system and we're going to verify that our answer makes sense. And we're going to answer in a complete sentence because this is a word problem. So I'm going to make myself some more room so that we can work through this problem. So let me go ahead and do that. There we go, that's better. Now, one thing that I notice about this setup for this system is that unlike the ones that we did in 1.4 part 1, it's not perfectly set up for elimination. In fact, equation 2 already only has 2 variables in it. So what I'm going to do is I'm actually going to rewrite equation 1 and equation 3 by plugging in that B is equal to 3A. So I know that B is equal to 3A, so I can substitute that in. So then I have a system of equations in 2 variables. I'm going to go ahead and do that. So I'm going to I'm going to write my little roadmap, my instructions. I'm going to rewrite number 1 and number 3 with B equal to 3A. So equation 1 is going to become, and I'm still going to call it equation 1, 75A plus, instead of 55B, if I multiply 55 by 3, I get 165. So 165A plus 30L equals 870,000. And then I can combine my 165 plus my 75. This is going to give me 240A plus 30L equals 870,000. Something else that I want to point out, and some of you I have seen already making these great decisions in class, is that all 3 of these numbers are divisible by 10. And right now they look really big. So I'm actually just going to divide everything in this equation by 10. So I'm going to have 24A plus 3L equals 87,000. Still a really big number, but at least it's smaller. And since this does not look a whole lot like my original equation 1 did, I'm going to call this equation 4. Now I'm going to take equation 3 and I'm going to plug in that B is equal to 3A. So I'm going to have A plus 3A plus L equals 23,000. So that's going to give me that 4A plus L equals 23,000. So now I can use these 2 equations, 4 and 5, which I should actually write that this one is 5, to solve a system of equation. And I have 2 variables, so I can go back to the Algebra 1, the basics of this, to solve this system. So I'm going to give myself some more room again. And if I'm looking at 4 and 5 and I want to solve those, I'm going to eliminate L because I see 3L and positive L. So I'm going to take 4 and I'm going to subtract 3 times 5, and this is going to help me eliminate L. So 4 is going to stay exactly the same. 24A plus 3L equals 87,000. And equation 5 is going to become negative 12a minus 3l equals negative 69,000. And when I add those together, I'm going to get 12 times a plus 0 equals 18,000. And now to solve for a, I can divide both sides by 12, and that's going to give me that a is 1,500, meaning there are 1,500 seats in section A. Now I need to figure out, because the question asked me how many seats are there in each section, I need to figure out how many seats there are in section B, and I need to figure out how many seats there are in section L. So I'm going to zoom out so we can see the whole problem. And I'm going to look at any of these equations that I have already been using and see what's going to help me. Well, I know that equation 2 says that B is equal to 3 times A. So if I know what A is, I can figure out what B is. So B is going to equal 3 times 1,500, and that's going to be 4,500. And I can look at any of the equations we've already used to figure out what L is. That's my only missing variable. I'm going to look at, I like 5. I'm going to look at number 5 to find L. 4 times 1,500 plus L equals 23,000. 4 times 1,500, that is 6,000 plus L equals 23,000. If I subtract 6,000 on both sides, I'm going to get that L is 17,000. Now, before I write my final answer out as a sentence, I want to make sure that this makes sense. First of all, these 3 values that I just found are supposed to add to be a total of 23,000 seats. Well, that works. I'm adding 7 and 6 together. That gives me 23,000. I'm supposed to have 3 times as many seats in B as I do A. Well, B is definitely bigger than A, and I can tell it's 3 times. Then I'm also looking at, we often don't have a picture, but I'm looking at this little picture, and it does make sense to me that the lawn area has the most seats, and that the area B has the second most seats, and that area A is the smallest number of seats. It make intuitive sense to me that that's what's going on based on that picture. So I'm going to go ahead and write my final answer as a sentence. So I'm going to say the amphitheater has 1,500 seats in section A, 4,500 seats in section B, and 17,000 seats on the lawn. And there we have our final answer. So again, the more important part in this lesson, more so than the solving, is the setting up. Can you define your variables? Can you identify the 3 equations from the words? We're going to work through one more example, start to finish, and then that's actually it for this section. So let's go ahead and get that problem ready. All right, number 2. Colin has $1.27 in quarters, nickels, and pennies. He has twice as many quarters as pennies. He has 11 coins in total. How many coins does he have? So what I'm going to encourage you to do is to pause the video and just define your variables. What letters are you going to use? What are the 3 variables that we're talking about? And then unpause the video and see how you did. So hopefully you did, in fact, take the time to pause the video and define those variables. I'm choosing to use Q for the number of quarters, N for the number of nickels, and P for the number of pennies, because that seems to make logical sense based on what we're talking about in the problem. Now I'm going to read through the sentence and try and see how I can come up with my 3 equations, knowing that the ultimate goal is to figure out how many of each coin Colin has. So first thing I notice, we're talking about money. I'm going to go to my green highlighter. We have $1.27 in quarters, nickels, and dimes. Now, I don't see a dollar sign anywhere else in this whole problem, which means if I'm going to have an equation that's all about money, I must need to use something that I already know about quarters and nickels and pennies that is maybe not listed in this problem. So what I need to use for my first equation is the fact that a quarter is worth 25 cents. So 25 times each quarter. A nickel is worth 5 cents. A penny is worth 1 cent. And I have a total of $1.27, but since I don't really want to work with decimals, I'm just going to multiply everything by 100. So I'm going to have 25Q instead of 0.25Q. I'm going to have 5N instead of 0.05N. I'm going to have 1P instead of 0.01P. And instead of having 1.27, I'm going to have $1.27. So I just multiplied everything by 100 just right off the bat. So he has twice as many quarters as pennies. So again, that means I'm either going to have 2 times Q equals P or 2 times P equals Q. So I need to ask myself, which one has more? He has twice as many quarters, so quarters is more. So Q equals twice as many quarters as pennies. 2 times the number of pennies is equal to the number of quarters. And then I need another piece of information. So what's the only number I haven't used? He has 11 coins total. So my third equation is going to be what kind of coins? Well, quarters plus the number of nickels plus the number of pennies is going to equal 11 total coins. So again, if you're doing okay getting here, that's the whole new part. After this, we're really just using the strategies we've been using to solve linear systems to get us the rest of the way through. So if you're feeling good right here, that's awesome. If you're struggling with the part afterwards, go check out the video before. So again, anytime we have a word problem, defining our variables, underlining, highlighting, circling, using color to set up those 3 equations, and then solving the system that you have left. So here, sort of like in the last problem, since I have the fact that Q equals 2P, I'm tempted to plug 2P in here and to plug 2P in for Q here to rewrite these 2 equations. So my first equation, so I'm gonna plug Q equals 2P into both 1 and into 3. So equation 1 is going to become, I'm going to give it a new name and a new number, equation 4. 25 times 2P is going to be 50P plus 5N plus P equals 127. And if I simplify this, I'm going to get 51P plus 5N equals 127. I'm going to do the same thing with 3. So 3 is going to become a new equation. I'm plugging in that. So 2P is where the Q is, plus N plus P equals 11. So 3P plus N equals 11, So now I can use equation 4 and equation 5 to eliminate a variable. Now these are not the nicest looking of numbers. I don't really want to multiply 3 by something to get 51. However, I will say that 3 times 17 is 51, so it wouldn't be terrible. I'm going to choose to use equation 4 and equation 5 to eliminate n. And what I'm going to do to eliminate n is I'm going to multiply equation 5 by -5. So I'm going to make some more room. So I'm going to keep equation 4 the same. So 4 is going to stay minus 5 times equation 5. This is going to help me to eliminate n. So 51p plus 5n equals 127. If I multiply equation 5 by -5, I'm going to get -15p minus 5n equals -55. And then I'm going to go ahead and simplify. 51 minus 15 is going to give me 36p. My n's are going to add to be 0. 127 minus 55 is going to be 72, so p is going to equal 2. There are 2 pennies. If I know p, that means going back to equation 2, I can figure out what q is. So use p equals 2 in equation 2. So q is going to equal 2 times 2, or 4. 4 quarters, 2 pennies. I just need to figure out how many nickels there are. I'm going to use p equals 2 and q equals 4 in equation 3 to figure out what n is. So q is 4 plus n plus p is equal to 11. So it looks like n is going to equal 5. I want to make sure that makes sense. I know I have the right number of coins. I could do the math to figure out how much 4 quarters is, $1, how much 4 nickels is, 20 cents, how much 2 pennies is, 25 cents, how much 2 pennies is 2 cents. So I do get $1.27, but it's really good to conceptually take the time to make sure that the numbers make sense, and then even mentally to do the math when you have the ability to do so. So to answer the question, I'm going to write this in a complete sentence. Colin has 5 nickels, 4 quarters, and 2 pennies. And there we have it. So I'm hoping that this is helping you understand how to define those variables, how to translate those English sentences into math sentences, so that you can set up your system and work through it and check that your final answer makes sense within the context of our problem. So go ahead and write down any questions you have, and I look forward to supporting you on this. Thanks for listening.